Working with fractions. First of all, I would like to clarify what is a fraction. So please check out here. So in our case, we are interested in fractions, so which are related to mathematics, right? So fraction has different meanings, and I think I have already seen some other translations in our glossary. So let me search for a fraction. So as you can see here, so this is the translation. Also, I could find it the second time. Somebody translated here as well. So I'm not sure if this translation correct, but I think the best way is to find fraction in Wikipedia, and I have already done this. So if you look here, you will find that this is a fraction. So fraction comes from the field of mathematics, and so the meaning should be related to maths. All right, so now I will write down some fraction. For example, 1 over 4. 1 over 4, right? So here we have two parts, the upper part and the lower part also. So the upper part is known as numerator. This is numerator, and so this part is known as denominator. Okay, denominator. Okay, numerator, again numerator, and denominator. So I hope you understand the meaning. So first of all, I will say 1, right, which is numerator, and then 4, right? 1 over 4 is a fraction again. So I hope you understand the concept. So if you find some mistakes in the glossary, so I suggest you to modify it. So please check out again. All right, so the question is how to work with fractions in Excel. How to work with fractions. Oh, you know that when we work in Excel, we mostly deal with decimal numbers. Decimal numbers. So using decimal numbers, I think is more convenient for engineers than fractions. But sometimes we also have to use fractions. And again, there are some occasions when we would like to do some arithmetic with fractions. So you can see a table here, right? A table here. We can find different fractions here. So let's say that you need to learn how to enter a number like 2 and 1/4, and how to have a number such as 14.667 displayed as the given one, right? So I think I already mentioned this, but I'm going to remind it once again. So let me delete unnecessary things, and let's select some of our cells. So don't forget that we have to check the formatting of a cell. So now, so what do we have here? The formatting for this cell is shown here, right? So now I have a percentage, right, for this cell. So I want to change it to a fraction. I want to change it to a fraction. So the question is how to do this. So let's do this together. I will select the cell, then here I will find a fraction. Okay, I can find fraction here. Or I can right click on my mouse and select format cells. You can see here, format cells. Okay, you can use these approaches. You can select it here, fraction, or you can right click and select format cells. As a result, you'll have such a window. In this window, you need to select the necessary category. Okay, so the necessary category. In my case, this is a fraction. So there are different types, up to 1 digit, up to 2 digits, up to 3 digits, and as half, as quarters, as eighths, as sixteenths, and etc. So I will select the first one up to 1 digit. Okay. So only then you can input a fraction here. Okay, 1 over 4. So 1 over 4 is what kind of value? So 1 over 4, and here we have 0.25. Again, I would like to remind you the terminology. Terminology is important for us. So this is displayed value. Displayed. This is a displayed value. Okay. And this is stored value. Stored value. Okay. Stored value. I hope you understand the difference. So, of course, usually such systems like Excel or MATLAB or Maple or Scilab, they use decimal numbers. So they use numbers with a comma, right? For example, 1.000, right? Or 1.5, right? So instead of writing 3 over 2, right, as a fraction, they use decimal numbers, okay? So they use decimal number. So it's more convenient for engineers to deal with decimal numbers. So working with fractions is not that convenient. But in some cases, it can help us to understand what do we really do. All right, so now let's try to format it. Again, right-click, format cells. In window here, you can select up to 2 digits. Up to 2 digits. Up to 3 digits. Let's select up to 2 digits. Okay. So nothing changes here in this case, right? Then we can select as halves, as quarters, as eighths, right? If you select as eighths, then you'll have 2 over 8, which is obviously equal to 1 over 4, right? This is just a different representation. So displayed value can change, but stored value, which is shown here, will remain the same. Okay, so Excel will compute based on stored values. You can display it as you want, but stored value will be used for other computations. Again, I hope you understand what is a fraction. Okay. All right. Again, this is the window where you can change the type. So you can scroll down here and select a necessary type. Dear students, don't forget we have different categories here. Again, I will translate what is a category so you will better understand the concept of category. Okay, this is the category. Okay, so now let's go to the next thing, actually, which is very important for us, copying formulas. So you already know what is a formula. We have typed some basic operations, right? For adding numbers, for multiplying numbers, for exponentiation. For all these problems, we used formulas. So what is a formula? This is a good question. What is a formula? So if you use Microsoft Excel and start it with equal sign and write something here, for example, sign of 1, right? Then it's a formula. So formula uses numbers. We can have a number here, and we can have functions. Okay? We can have numbers, we can have functions, we can have some other arithmetic operations, which we actually discussed today in the order of precedence. This is the formula. If you miss the equal sign, then it will not be a formula, but it will be a text. Okay, so again, don't forget to miss the equal sign. So start any formula with an equal sign. Then at the end of the formula, you need to press enter. Now I'm pressing enter. Okay, now I have the answer here. So the answer is not a decimal number. Why? Because here the type is a fraction. If I change it to another format, so better to select number format and add some decimal places, for example 2 decimal places, then I will have a different representation here. So when engineers or scientists compute some values of functions, and here we have a sine function. So as you know, sine is a trigonometry function. Trigonometry function. So if you compute trigonometry functions in Excel or any other computer algebra system, then of course it's better to use decimal numbers. Okay, decimal numbers. So decimal numbers are more convenient for us to for computations. Okay, the next thing, the next question, how to copy a formula, how we can copy a formula. Let's see together. So we can easily copy some objects, right? But now we need to copy a formula, right? Formula is not a picture. You can easily copy and paste the picture. You can replicate it. But it's something not exactly the same in formulas. Actually, we can copy formulas. So to copy a formula, so you need to perform the following actions. So first of all, you will bring the cursor of your mouse here. Okay, you can see a cross here. I'm bringing my cursor here to the right bottom corner of this cell, right? Then I have some cross here. Then by using a left button of your mouse, you need to drag it down. You need to drag down. Okay. So now I have copied the cell B4, the formula in cell B4 to other cells. Now let's check out the content of these cells, and I have exactly the same value in another cell, so it's 0.84. Let me now check the formula. Is it the same or it's different? So here we have a sine of 1, right? Sine of 1. In this cell we will have exactly the same, right? Here and here we have exactly the same formula. So by dragging this formula down, I have copied it. Okay, I have copied. Okay, so the question is, what is a relative address and what is an absolute address? This is a good question. So cells may have a relative address and absolute address. Okay, so we have two types of addresses. First of all, I want to explain you what is an address. Okay, first of all, please look here. So I use some formula. So what is the address of this cell? What is the address? So this cell is located on the intersection of column B and row 4, right? So the address is B4, okay, B4. This is the address of this cell. So finding address is very simple. First of all, you will check the column, right, then you will check the row. Okay. So we can define address not only for one cell, but for several cells. Let's say I will copy it here. And so I want to define the address for these 4 cells. So now actually I have not only one cell. Here I have a range of cells. Range of cells. Okay, range of cells. Range means several cells. So let me use some kind of lines here. So I will just use hatching. So this range starts at B4, right, and ends at B7. So the address is B4, then I use column. So column means 2 lines, B4 to B7, okay, B4 to B7. This is the address. This is the address of the range of cells. So now let's modify something. Okay, and now let me copy this one to the right here until here. Okay, now I want to define the address of these cells. So let's check it out together. So I want to define the range of these cells. Okay, these cells, this range of cells, right? This range of cells. Okay, so we start from the left upper corner from here, right? So what kind of cell is it? B4, right? B4. And we go diagonally to the lowest right corner. This is D7, right? B4 column D, what? D7. So this is the address of the range of cells. So not only one cell, but also a range of cells may have their address. Okay. So moreover, instead of using address, we can use some name. We can use some name. And now let me show it to you. First of all, I will delete. I'll delete this one, and I will delete this one. Okay. So now, what is the address of this cell? So the address of this cell is what? Is B4, right? Also, it can be found here, B4, okay? B4. So instead of B4 here, I can define some name. So the name should be unique. So we will discuss this later, but now I will just type. So let's say I will define it as my x, okay, my x. My x means my x value. Then I have to press enter. Okay, now instead of B4, I have a name for this cell, right? The name is shown in here, right? Instead of B4, I have my x. So if you define a cell, or also you can apply this to a range of cells, then you can use this name. So don't forget that the name should be unique. And you cannot use some special functions from which are already existing, right? So you cannot define it as a sin, for example, as a sign. So it should be a different name. Now here, I will do this one. So I will use my x, right? My x, which is in B4, right? And I will multiply it by 5. Okay, so I'm adding some formula. So formula can contain numbers, it can contain functions, and also it can contain a reference to a cell, right? It can contain address of some cell or range of cells, and also it can contain some names of a cell or range of cells. Okay. So several things can be included here inside your formula. So if you use everything correctly, then you will see that there is a different color. So now I have a blue color here. So my x is in blue, and also this cell is highlighted by blue color. It means everything is okay. Then enter. So now is computed. Okay. If you change here, for example, 2, right? Then, so it will be recalculated or recomputed. So this is important to know, right? So we have address not only for one cell, but also for a range of cells. Also, name can be given to the range of cells, and we will do this kind of things in our next lectures. So, a good question, dear students. Again, what is the difference between absolute address and relative address? So, what is the difference? So, what kind of addresses they are? So, here I have given some example to you. Okay, but first of all, again, let's return to my worksheet. I will return to my worksheet. Okay, here I will use, let's say, I will store some data in B4, and here I'll use some formula. Let's say I want to multiply B4 by what? No, I will delete this. I will use only cells. Okay, B4. Let's say I have 2 here. And here I want to use B4, right? And multiply it by, or I will take a power. To the power of 3, let's say. So I think you understand this symbol. So we use it for exponentiation. Exponentiation means to the power, right? B4 to the power of 3, right? Enter. You'll have 8, right? So now we have a formula here. So the displayed value is 8, but if you check here, we have a formula in this cell. So the question is how we can copy this formula, how we can copy. We can copy it in the same way as shown before. You will select the cell. And in the right, actually bottom corner, you will find some cross here. Okay, when you approach it with the mouse cursor, okay, you can see the. So then we can copy. So let's copy it. Okay, I think it's enough. But the result is quite strange, right? So the question is what happens here? Let's check the formula. Again, B4 to the power of 3, right? B4 to the power of 3. Let's go to the next cell. Here we have B5 to the power of 3. The question is, so why this blue rectangle has moved? Why? Very interesting, isn't it? Okay, let's go to the next cell. I will select the cell and click here in the formula bar. And again, blue rectangle is moving down. The question is why? The question is very interesting, and if you look here in this cell, so we used a relative formula. A relative formula is used. So what does relative formula mean? So relative formula means if you copy it to down, up, or left or right, so it will change, right? It will change the formula. So we can copy up also, right? We can copy left, but for simplicity, we can copy down and we can copy to the right, right? So now let's copy to the right. Okay. And check what happens. Again, here we use this cell and power of 3, right? Then let's go to this cell. So what do we have here? I copied formula to the right, and this blue rectangle also moved to the right. Very interesting. The next cell, I copy to the right, and this rectangle moved to the right. So by copying relative address, so the things also will change, right? So I'm copying formula, and a reference to some cell is also changing. Why? Because I'm not using absolute address. So I'm using relative address, okay? This is a relative address. So if you look here, there are several examples how we can write an address in a cell B1. So we can use actually dollar symbol here. This is dollar symbol. So B1, B $1, dollar B1, dollar B $1. Okay. So these are 4 ways to write relative and absolute addresses. Okay. Okay. So among them, the absolute address is this one. This is the absolute address. So when you type the address to a cell in this way, you can copy it anywhere and it will not change. Let's test it together. So now I will select this one, this example, and I will try to implement it. Okay, so let me go back to Excel. Okay, B1. It should be in B1. I will delete not necessary things. Okay, B1. Okay, for example, I will use 2 here. Okay. And somewhere here, I will use a formula. So it equals to, let's say, 2 times, or no, I will write first of all dollar sign, B $1. Okay. Now you can see the cell has been highlighted with a blue color. Then let's say to the power of 2. Okay. So this is an absolute address. Okay, absolute address. This is not relative address. Absolute, because I use $2 but here, right? This is an absolute address. Okay. So now let me copy it. I will copy to the right. I will not copy to the left. And I will copy to down, not up. But you can try both of these and it will work in the same way. Okay, first of all, I need to press the enter button so that the formula will be computed. Enter. We have 4, right? This is correct. So if you change it to 3, you'll have 9 here. Okay? So it will be recalculated quickly. So now let's move it. Let's copy it to the right. Again, I will bring my mouse cursor to here. Cursor. This is a cursor, and I'll bring it here and copy here. 1, 2, 3. Okay. Now I can see that when I copy the formula remains exactly the same, right? So we have B1 with $2 to the power of 2. The same here. So formula is not changing, right? It's not relative formula. It's an absolute formula. So now I'll copy it down here. 1, 2, 3. And check the formula. Again, the formula remains the same, right? The formula remains the same. You can easily select this all together, and then you can copy all these cells down, okay? In this way. Okay, now we have copied the formula. So how many times? We have 16 cells now, and everywhere you will find the same formula. Why? Because this is an absolute address of cell B1, okay? So before B and before number of row, we use a dollar sign. Okay, I think you know how to use dollar sign. So if you don't know, you can practice. So shift 4. Okay, shift 4. All right, here shift plus 4. Okay, then you will get dollar sign. Again, this is an absolute reference, okay, or absolute address. I will highlight it, absolute address, okay? Okay, absolute address. So now let's try some of this. So we can use dollar sign just before the line number or before column number. And let's copy this formula and see what happens. So what is the difference? Okay, I will delete this one and I will delete this one. Okay, now I'll modify the formula here. So now I will remove the dollar sign just before the column number, right? Column B. Enter. Okay, exactly 4. Now I will copy it here to the right. Okay, as you copy here, so the formula is changing, right? Instead of B, we have C, right? So there is no dollar sign here. Then let's go here. We have D here, right? So it's moving. Here we will have what? We'll have E. Okay. Now I'll copy it down. 1, 2, 3. Okay, and here I have exactly the same, right? So the formula is exactly the same. So if you copy it to another column, then it will change. But if you don't copy it to another column, but copy it to just different rows of the same column, it will remain the same. Okay, so this is the what actually for we use such a formula. So I hope you understand the difference. So now let's modify it. So instead of using dollar here, I will use it in this way. Okay. So now I'm using dollar sign nearby B, but not before 1. Enter. Okay, this cell will be computed without problems. But when you copy the formula to the right, so you will see that the formula actually not changing, right? The formula is not changing. So we have the same formula here, here, and also we have the same formula here. So when you copy it to another rows of the same column, as you can see here, we don't have any dollar sign just before row number, right? Let's see what will happen. You can see that the formula is changing, right? The formula is changing, and as a result, we have some strange answer here. Okay. Okay. So I hope you understood the difference. Sometimes we need to use absolute address. Sometimes we need to use relative address. So if you want to, it depends on the problem you solve. Okay, let's try to do some small example. I think it's very useful. Actually, this example is known as multiplication table. I think you all know what is multiplication table. You like, I think, multiplying numbers. Probably you learned some kind of device like abacus. So in the previous week, I explained you what is an abacus, and I think you already have such experience. So instead of using abacus, we can do this in a smart way, and in a fast way we can easily multiply numbers. Okay. So now let's create this multiplication table. So this is multiplication table. So what we need to do here, I will explain to you. So suppose we'll be given some numbers from 1 to, let's say, 10. Here you can see 5 only, but anyway. So we have numbers 1, 2, 3, 4, 5, right? The same here, 1, 2, 3, 4, 5, right? So now we want to multiply them. So for example, 1 times 1. 1 times 1 is 1, right? Then 1 times 2. 1 times 2 is 2, right? And etc. So I want to use some formula to quickly compute all this. Quickly. I want to quickly compute. Compute quickly. By using only one formula. So you will write down only one formula into this cell, right? And then you will copy it, and as a result you will have a multiplication table. Okay, so let's do this. Actually, the hint is already given here. The hint is given. So now we need to implement it. Let's try to implement. So we will start with the cell what? I think this is G1, right? G3, right? Where is G3? Okay. I will exactly use the same cells, addresses for simplicity. Okay, here we have 1, then, and then H2 we have also 1, right? So I want to create a multiplication table for numbers from 1 to 10. From 1 to 10. So I need to write all these numbers here. So it will take a long time, right? I can write 1, 2, 3, right? So it's a long time. So smart people use another ways. The same here, right? 1, 2, 3, 4. So then sometimes we need to write until 100, right? So it's you don't need to do this. If you're a smart person, of course, and I believe that you understand what I'm saying. So I will select this cell. I'll select this cell, okay, and try to copy. So when I copy it, the number is not changing. The question is how to actually do in this way so that numbers will change. So firstly I will have 1, then 2, then 3, then 4, and until 10. The question is how to do this. Okay, I'm going to explain it to you. Let me erase it. So please select the cell. Firstly select the cell. Then, so bring your mouse to this corner until you see the cross here. You can drag it down, but in this way you will only copy it. So I don't need to copy it because I have another problem here. I need to create a multiplication table. So I will press Control button. Control. I think you know what is a control. CTRL. Okay. When I press Control button, you will find a small cross in the superscript of bigger cross. You can see it here, right? So then hold it, please. Hold Control and drag it down. Drag it down until you reach 10. Okay, now you have everything here from 1 to 10. So you don't need to type by yourself. The same here. Bring your mouse cursor to the right bottom corner until it becomes cross. Okay, once again. Okay, so then press Control button again. Control. When you press Control button, you will find another small cross, right? Then hold it, please, and move to the right. Drag it to the right until you reach what? Until you reach 10. 8, 9, and 10. Okay, here. Of course, you can move more. You can move more if you want to produce a larger multiplication table. In my case, I need only numbers from 1 to 10. Okay? Okay, now let me select it. I will center everything, and also I will use borders here. I'll use all borders just over here. Okay, so now I want to compute it, everything. So here means what? 5 times 4, or 5 times 5, right? So I want to do it quickly. So I will now just use only one formula. So the example is given in my presentation, so please check out this formula. Don't forget, we'll type formula only one time, and formula should start with the equal sign. Equal, then $G3, right? So I will use this number, these numbers, right? So then times means multiply, multiplication symbol. Then H $2, okay? I'll use this cell. Enter. Now it's computed, okay? So now I'll copy it to the right here. I will copy, and let's see what happens. I have two numbers, 1, 2, right? So this is correct. Here I have a 1 and 3, okay? Let's copy down here and check how it works. 2 times 1. Okay, great. The next one is 1. Yeah, 1 times 3. Yeah, everything is correct. So I will delete this. So now we have only one formula, and we can easily copy it. I will copy in this way, so please follow my instructions. So if you want to copy, you don't need to press Ctrl, just bring your mouse to this right corner, right, and drag it to the right here, okay, like this. Okay, now everything is copied. So now the range of cells is selected. So please keep it selected. So if it's selected, you can copy all these down. I will again bring my mouse to this corner of the range of the cells, right? And copy it down in this way. Okay. We have a multiplication table, right? We have a multiplication table. So in a very simple way, we have constructed the multiplication table. Okay, so it was very quick and very easy. So you can multiply actually in such a way. You can increase the number of numbers, and by adding a formula in a smart way, so you can create a multiplication table for larger numbers. So you can apply this method for various types of problems, not only multiplication table. Now let's return to names. Again, I would like to remind you that using names is an alternative to using absolute references. So we can give a name to a cell in such a way, right? So first of all, please don't forget, we have to start with equal sign, right? So we should use equal sign. So without using equal sign, our formula will not be computed. So then we use some reference to a cell, right? And then we use what? We use a name. Let me write it again here. So in this formula, so we have an equal sign. So then we have a A4 is a cell reference, and this is a name, right? Name. name of a cell, or also, as I told you before, we can use it for a range of cells. For example, what kind of range of cells? We can define a name, for instance, for a vector. Or we can define a name for a matrix, or the range of cells. So as you know, in matrix we have a number of rows, and also we have number of columns, right? This is not only a one cell. So now let's define a name to a cell and to a range of cells. So let's say I have a reference here, B3, right? I will keep something here, for example, 2. So then we can do this in several ways. The first one is just go here, just below the clipboard. You can modify it. You can assign a name to this cell here, to B3 cell. Or you can go to formulas panel here, and also you can find define a name. Okay, define name. But I prefer using Home tab and writing in here. So I'll write something. Okay, so last time I have written my x. I will write the same, my x. Okay, this is the name of my cell. So instead of using reference, now I can use this name again. So names can be used for absolute references. Okay, absolute. They are absolute. So if you copy my x somewhere else, so it will be my x, right? So for example, I can write here my x, right? Enter. It will be my x. My x, right? Everywhere we'll have 2. Okay. Now let me delete this. Okay. So now let me form a matrix. Let's say 1, 0, 0, 0, 1, 0. Then here we have 1. Here we have 0 and 0. Okay, this is a matrix. So as you know, matrices are often used by engineers. So usually students study matrices in the field of linear algebra. I think you will also study matrices, but I don't know when you will do this. So we have a matrix. So 3 by 3. We have 3 columns here. 1, 2, 3. 3 columns, 3 rows, sorry, and 3 columns. 3 by 3. So now, the address for this is what? What is the address? So the address starts from B2, right? From B2. We start from B2. From this element, right? B2 column. We use column until D what? D4, right? Until D4. D4. Okay, D4. This is the address. Okay. So now I want to give a name to this range of cells. I want to give a name to this range of cells, or to this matrix. I will select it. Here, right? And in the same way, so just below the clipboard, you will find here, right, the name box. Let me say my matrix. Enter. Okay. So now, when you select one of these elements of a matrix, this one or this one, you won't find this here, the name, right? So you have to select the whole range of these cells. When you select the whole range, you will find my matrix. Okay, my matrix. So if the name is defined, then you can do some operations with this matrix. So for example, you can multiply one matrix by other matrix. I will show you some examples in the next lectures. So now we just define the name for a range of cells. Okay, so names are treated generally as absolute references. So copying the formula from A8 to A9 would result in equal A5 times adjustment, right? So it will not change. This is an absolute reference. You will not have adjustment 1 or adjustment 2 here as soon as you define the name in this way. So, of course, there are some more complex ways of making relative names, but this is more complex, and we will not even talk about this. So, you also should know that names are case insensitive. So, what does it mean? Case insensitive. Case insensitive. So what does it mean? For example, you define a name in this way, adjustment, right? A is capital and other letters are small. Or you can use adjustment with all capital letters. So this is the name of a cell, right? Or you can use only small letters in a formula. It's case insensitive. So all these should work. So let's check it out. I will delete this matrix. Okay, I'll write 2 here. Let's say the name is my x. Enter. Okay. Okay. Now I'll try to write it here, my x, in this way. So it defines the cell, right? B2. Enter. Now I'll write it in this way. So small m my x. Okay. So I write with small letters, as you can see here, and also it defines this cell. Enter. So it works. Let's say you want to multiply it by and capitals, multiply, or plus 2, let's say plus 2, enter. So it works. So that means so here names are case insensitive. Case insensitive. So case is not computer-aided software engineering here. This is a wrong meaning. Case insensitive. Again, I would like to point out that names also can be given to range of cells. So please don't forget this. And the matrix or vector is one of such examples. So some other examples, so please look here. So we can have something simple, right, or even something more complex. So a name always refers to a formula. So formula may contain some actually cells from another pages, right, or another sheets. As you know, in our actually workbook, we have several pages, right? So we call them sheet 1, sheet 2, and etc. So if I want to use something from another sheet, I will use equal sign first, then go to sheet 1, for instance, select some cell, let's say I7, return back, so it defines I7 cell from sheet 2, plus 5, for instance. Okay. So if you see something like this one, so then it means the cell is from another page, from another sheet, okay, from sheet 2. So I7, right? So you need to be very careful with formulas because sometimes you may have some strange things. So you have to understand how formulas are written and how they are working. Next and the last for this lecture are mathematical limitations of Excel. Mathematical limitations. Some things are very interesting here. So we have some, of course, many advantages in electronic spreadsheets. You know, Excel is one of the electronic spreadsheets. So, like most computer programs, Excel uses the IE754 standard for storing numbers. A number is converted from digital to a 64-bit binary representation. Okay, binary representation. So Excel uses 64-bit binary representation. So the fact that a finite number of binary digits are used has two major implications. It limits the range of numbers that can be stored. So Excel can store positive numbers from this value, right, from this value until this value. Okay? You know what does it mean? E308. It means 10 to the power of 308. Or minus 308, right? So big number and a small number. So it's often stated that Excel has 15 digits precision. But this is not quite true. What is true that Excel truncates, so it truncates. So it truncates its stored or computed values to 15 significant digits. So what does it mean? So let's test it together. I will create new sheet, new page, and I will zoom in to see better. So let me write some a long number. Let's say, first of all, I will use Notepad. So I will write some number 1, 2, 3, 4, 5, 6, 7, 8, 9. Then again 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is a very big number, a very large number, and we have how many digits do we have here? So we have 9 digits. Then we have a second 9 digits. So totally we have 18 digits, right? 18 digits in this number. So now let's store this number in Excel. Let's store it. Let's keep it in a cell. Okay, I'm copying this. Then let me place it here. First of all, I will check the format. Format is general, but I will change it to numbers. Okay. Okay, here I don't use any formula, so you don't need to use equal sign, only input a number with 18 digits. Enter. So you can see what happens. What happens is very interesting. Now let's check it out. So this is the displayed value. And it looks like the displayed value, so the value which you see, is exactly the same as stored value, right? Exactly the same. So now let me copy it. Let me copy it. And I will return to my Notepad so that you will see the difference. So, dear students, what are the differences here? So as you can see here, so until this digit, numbers are coinciding. So they are exactly the same. But last 3 digits, here we have 7, 8, 9, but in Microsoft Excel we have 0, 0, 0. So what happened? We had 18 digits, but instead of 18, I can see only 15 digits, and other digits are replaced by zeros, right? So if you use a larger number, you will have more zeros. Let's say I will add again. I will add 1, 2, 3, 4, 5, 6, 7, 9, right? And so here, how many digits I have? I have 27 digits, right? 27 digits. Okay, let me copy it. I'll paste here. Enter. So here I have different representation. So this means 1.23457 times 10 to the power of 26. Okay. So I hope you understand this kind of representation. Actually, engineers and scientists, they often use this representation. So in my case, let me try to change the formatting. I will select the cell, right-click, Format Cells. I will select number here, and so I will use number here. I don't need any decimal places because this is an integer number. Okay, so what happens now? What happens now? The number you see is called displayed value. This is a displayed value. So displayed value also has a lot of zeros, right? But stored value is different. Stored value looks like different. So if you count this, so you will again have 15 digits here, right? Until 6. Until 6. So other digits are replaced by zeros. Other digits are replaced by zeros. So that means you will have zeros instead of remaining digits. So what does it mean, dear students? So if you have a large number and if you want to store it in Microsoft Excel, it will store it, but what? But as I mentioned, what? So Excel will truncate its stored or computed values to 15 significant digits. So the first 15 digits will be significant. Excel will not care about other digits. So, as a result, we may have errors if we work with very large numbers. So we need to be very careful with this. So, so other digits are replaced by 0, right? And it's not rounded. They are simply replaced. Instead of 7, Excel uses 0. Instead of all other digits, we use 0. And obviously, so these two numbers are totally different. They have very huge difference. They have very huge difference. That means working with very large values may bring some errors to your computations. So you need to be very careful. This is an example. Yes, again, very simple. So the precision is lost. Precision is very important for engineering and also for science. So without precision, I think it's very hard to do some important, for example, designs, right? Precision and accuracy are very important concepts. Also, it often comes as a big surprise to many users that Excel or many other computer applications cannot represent some real, means non-integer digital numbers with total accuracy. So you know what is a real number is shown here. So one good example. So think about the fraction 1/3. So we cannot display its value with complete accuracy in the decimal notation because it will be stored as 0.333. Okay, let's test it. So I will open a new page here. So 1/3 is a fraction, right? So this is, let's say, is a number here. So 1/3 is a fraction. So here you will see 0 because this is displayed value. You need to format the cells. So the things are depending on the number of decimal places. So you can increase the number of decimal places. Let's say I will write 20. I think 20 is enough. Okay. So what is 1 over 3? Well, 1 over 3 is equal to what? 1 over 3 is equal to 0, comma, right? Comma 0. No, not 0, 3. 3, right? 3. So 3 never stops and it continues until infinity, right? Infinitely. But here you can see that we again have some problems, right? So the first, how many digits? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So only 15 digits are shown. So other digits are replaced by zeros. Okay, and here, this is displayed value. You can see zeros, but in stored value, you see nothing, right? So it's we have 0, so it doesn't have any meaning to write it. If you write 0, it's no meaning here because it's 0, right? So these are the limitations of a software, and Excel is also not so excellent in this. So we may have some problems with accuracy. Again, accuracy is important for engineers. So, dear students, I suggest you to check out the our textbook. Again, you can find the title of the textbook in our syllabus. So for now, thank you for your attention and have a good day.